Okay, we're going to look at solving exponential equations. Now, on these particular equations, what we're looking to do is to make everything have the exact same base. And once we do, we're going to drop the bases and take the exponents and set them equal to one another. So if you're looking at number 1, you've got 2 to the x plus 1 equals 2 to the 9th. Do you see how both of these have the same base of 2? Because both of them have the same base of 2, we're able to take the exponents x plus 1 and 9 and set them equal to one another. And once you do that, you want to solve your equation for x. And here we'll get x is equal to 8. Now, once you get to number 3, we have a little bit more than what we did in number 1. When you are solving an exponential equation, you have got to have the same base. So, all 3 of these are base 3. But on the left side, there's 2 of them. We only need 1 on the left and 1 on the right. So we have to use our property of exponents rules. The properties of exponents tell us that when we are multiplying with the exact same base, we can add our exponents together. So take your base, which is 3, and bring it down. Do not, and I repeat again, do not multiply those bases together because they're taken by those exponents. So add your exponents. 1k plus 1k is 2k plus 2. And it's going to equal the other side, which is 3 to the 5k minus 1. So now we see that we have a base on the left of 3 and a base on the right of 3. Since we have 1 on each side, we can drop the bases and set our exponents equal to one another. Now we're going to solve this equation by moving our variables all to the same side. I'm going to start with the 2k and I'm going to subtract 2k from both sides. That's going to give me 2 is equal to 5 minus 2 is 3k minus 1. Now to solve for k, we're going to get rid of the minus 1 by adding 1 to both sides. 2 plus 1 is 3. That cancels out, giving us 3k. Now we'll divide both sides by 3 to get k equals 1. Once we get to number 5, we can see that things are starting to get a little bit more difficult because we no longer have an equation with the same base. We have 2 different bases. So we have a base of 6 and a base of 36. So my best advice to you is to start with the smallest base and see if you can raise it to a power that will give you the other base. So since we have 6, we know 6 to the first is 6. And 6 to the second is 6 times 6, which is 36. So that's what we're going to use is a base 6. Now 36, as we can see, is 6 to the second power. And since I've changed 36 to 6 to the second power, I now have the same base on both sides. So I can drop the bases, and I can solve this equation for x. To solve, we're going to add 10 to both sides. That'll cancel, giving me 2x is equal to 12. Now I'll divide both sides by 2 to get x is equal to 6. On number 7, the first thing that catches my eye is I have base 7s, but this base 7 is in the denominator. So anytime you have a denominator, what you want to do is you want to bring it up to where the numerator is. So when I move a number from the denominator to the numerator, what's going to happen is it's going to change my exponent of 1 to a negative 1. When you change position, you change the sign of your exponent. So now we have 7 to the 4x plus 11 equals 7 to the negative 1. So we have the same base, 7 and 7. Drop the bases and solve your equation. Let's subtract 11 from both sides. These 2 will cancel out. Over here, we have negative 1 minus 11. That's same signs, so we'll add and take the sign. Now we're going to divide both sides by 4 to get x equals negative 3. Looking at number 9, we have a base of 27 and a base of 3. Like I told you before, start with the smallest base and see if you can multiply it to get the other base. So 3 to the first is 3. 3 to the second is 9, and 3 to the 3 is 27. 3 times 3 is 9, 9 times 3 is 27. So I can change 27 to base 3. Now when I do that, I've got to remember that it's already raised to a power of 2x plus 6. Okay, so when I change 27 to 3 to the third power, it's got another exponent up there of 2x plus 6. I've got to take these two exponents and make them into one exponent. To do that, I'm going to have to multiply my new exponent times my old exponent. And since this is an addition problem, I'll have to use the distributive property. 3 times 2 is 6, and 3 times 6 is 18. So I have 3 to the 6x plus 18 is equal to 3 to the 2x. Now I have my same base, 3 and 3. So let's take 6x plus 18 and set it equal to 2x. Now normally I would move my smaller variable to my larger variable, but by doing that I create a 0 over here and extra steps. So instead, I'm going to move the 6x to the other side by subtracting it. These two will cancel out, and 2 minus 6 is negative 4. So now I have 18 is equal to, and I'll divide, and I'll get x is equal to negative 9/2. Okay, let's turn the page and look at the back. When you look at number 11, we have 125 and 25. So take that smaller exponent, 25 to the 1 and 25 to the 2, and I see that I can't change 125 to a base 25. So I've got to come up with something else. So since 25 won't work, I know both of them end in 5, so let's use 5. 5 to the first power, 5 to the second power, and 5 to the third power. That's it. I got 25 and 125. So I'm going to replace 125 with 5 to the third power, but don't forget there's a y up there as well. Then I'm going to replace 25 to 5 to the second power. So 5 to the third times 3. When you have a power next to another power, you have to multiply those two exponents together. Now I have the same base, so I can drop the base and solve for y. Okay, now looking at number 13, if I use my smaller base, I see that I cannot get the same base using base 4. So instead, let's try something else. Instead of 4, we'll try 2. And that's going to be it. So I'm going to replace 4 with 2 to the second power, but I further have to raise that to the 3x. I'm going to replace 8 with 2 to the third power, but I further raise that to x minus 1. Again, you have to multiply these exponents together. 2 times 3 is 6x. Over here, I've got to multiply 3 to x minus 1, so I'll need to use the distributive property again. 3 times 1 is 3x. 3 times negative 1 is negative 3. Now I can set both of these equal to each other, and I can solve by subtracting 3x from both sides. When this cancels out, minus 3 is negative 3. Then I'll divide both sides by 3 to get x equals negative 1. All right, looking at number 15, I've got base 8 and base 32. So using base 8, I see that I'll be unable to make the same base. Okay, now my next option with 8, I could use 2. Okay, so once I get to 2 to the 5th, I see 2 to the 5th is this 32, and 2 to the 3rd is 8. So I can replace both of these with base 2. 8 is 2 to the third, and 32 is 2 to the fifth. Okay, so I need to take these two exponents and multiply them together. So I'll multiply 3 times 2a minus 1, and I'll multiply 5 to 2a plus 1. So bring down your 2. 3 times 2 is 6a. 3 times negative 1 is negative 3. Bring down your base 2. 5 times 2 is 10a. 5 times 1 is 5. So I have my same base, so drop the bases. And let's solve. Subtract 6a from both sides. The minus here becomes a negative. Subtract 5 to get rid of your constant. This is same signs, add and take the sign. So a is negative 2. Okay, so looking here, I have two 4s. My first order of business is to make one 4. I don't need 2. So when you multiply with the same base, you add your exponents. 4 has an understood exponent of 1. So that's going to give me 1 plus 4x. Now I need to figure out what base to use. So using 4, I've got 4 to the first power, 4 to the second power, and 4 to the third power. So that's exactly what I'm using. I'm going to replace 64 with 4 to the third power. And now 3 equals 1 plus 4x. Subtract 1 from both sides and divide both sides by 4. You get 2/4, which reduces to a half. And finally, number 19. I see the first thing is 1/7, so I'm going to move the 7 up to the numerator. When you go from the denominator to the numerator, your exponent has to change signs. So 7 to the first power will become 7 to the negative first power. Now with 49, I'm going to change that to 7 squared, but I'll have to multiply it to the exponent that's already there. So take your 2 and multiply it to x minus 5. So I'll have 7 to the negative 1 equals 7 to the 2 times 1, that's 2x, and 2 times negative 5 is negative 10. Now I have 2 7s on the right side, and I don't need that either. So when you multiply with the same base, add your exponents. 2x plus 1x is 3x. Negative 10 plus negative 9 is negative 19. And I finally have the same base. So drop your bases and solve your equation. Let's add 19 to both sides to get 3x equals 18, and divide both sides by 3 to get x is equal to 6.